Hey everyone, and welcome to this tutorial series on Raspberry Pi for complete beginners. The video you're watching now is actually the complete series that I've put together in just one big video. In this series, you will get started with Raspberry Pi step by step in a practical way. If you don't know anything about Raspberry Pi, this tutorial series is for you. And if you're already familiar with the board, but you feel like you could need a quick refresher of the basics, well, the tutorials are also going to be super helpful. In this series, you will set up your Raspberry Pi without even needing an external monitor. You will learn how to use the GPIO header to control hardware components, how to create a web server hosted on the Raspberry Pi, and much more. And just before we get started, this tutorial series is actually a free extract of a much longer Raspberry Pi course. If you are interested, check out the link in the description. And now let's get started with the series. In this first video, you are going to understand what Raspberry Pi is exactly, and let's start. What is Raspberry Pi and what can you do with it? The Raspberry Pi is a very small computer the size of a credit card, but it is quite powerful and it can run a lot of applications. So what can you do with this board? And this is where the Raspberry Pi truly shines. Here are some examples of projects you can easily make with a Raspberry Pi. You can automate your home, make your personal devices smarter with IoT or Internet of Things. You can also build a retro gaming console, create a security or an alarm system, host a server for a web or mobile application. You can even run a Minecraft server on your Raspberry Pi. Program robots such as robotic arms, drones, hexapods, mobile robots, etc. Create a smart mirror. You can also install different operating systems, for example Raspberry Pi OS, Ubuntu, Windows IoT, and much more. Or simply use the Raspberry Pi as your own portable computer. And of course, this list is far from being exhaustive. You can find much more projects online, and you can also get inspired to create your own custom projects. One great thing about Raspberry Pi is the community. So, what does the community bring to you? Well, for example, you can see what other people do with their Raspberry Pi. You can ask questions, get some help for more advanced users. You can also collaborate with other users on similar projects and progress together. Raspberry Pi is created by the Raspberry Pi Foundation. The goal of the foundation is to make computers and digital making available for everyone across the world. For less than $40, you can get the Raspberry Pi board and the complete setup with computer, screen, keyboard, and mouse would cost you less than $100, which is a very good first step when you compare this price with the price of any other computer or laptop available on the market. The first Raspberry Pi board was released in 2012. Then, the foundation has continued to develop new iterations to make the board more powerful, add more functionalities, make it easier to use, and develop the community. In 2015, the Raspberry Pi 2 was released, with much more computation power than the first one. Then the Raspberry Pi 3 came in 2016 with again more computation power, and this time the Wi-Fi feature was directly integrated in the board, so you don't have to use a Wi-Fi USB dongle anymore. Today, the latest version is the Raspberry Pi 4, released in 2019. This new version is really great, much better performance than the version 3, a few changes in the external connectors to make it compatible with modern applications, and an increased amount of RAM. In fact, with Raspberry Pi 4, you can even choose the amount of RAM you want. The Raspberry Pi 2 and 3 had 1 GB of RAM, which was already good. Now, for the Raspberry Pi 4, you can choose between 2 GB, 4 GB, and even 8 GB of RAM, which is huge for that board. At the beginning, the Raspberry Pi 4 was also available with 1 GB of RAM, but not anymore. Now, what can you find on the board? Here you have the CPU, RAM, Wi-Fi and Bluetooth chips, and all other components required to make the Raspberry Pi work. And let's focus on the connectors. You have one Ethernet port with Gigabyte Ethernet, 4 USB ports, including 2 USB 3 ports in blue, one USB-C port to power on the board, 2 micro HDMI ports with 4K video support for 2 external displays, a jack audio output port, one display port for the Raspberry Pi touchscreen, one port for the Raspberry Pi camera module, a micro SD slot on the back of the board, and actually you will install the operating system directly on a micro SD card, and finally you have a 40 pins or GPIO header to control different hardware components. GPIO means General Purpose Input Output. This header is the same for the Raspberry Pi 2B, 3B, and the Raspberry Pi 4. Welcome back, this is episode number 2 of this tutorial series on Raspberry Pi for complete beginners. The very first step before using the Pi is to flash an operating system on the SD card you have and do some configuration. In this lesson, I will show you how you can easily install the Raspberry Pi OS on your micro SD card, but also how to set up the Wi-Fi and an SSH connection so we can get access to the Raspberry Pi. So you can start by going on Google and just type Raspberry Pi and go to raspberrypi.com. So raspberrypi.com and then just go to software here. So you should have raspberrypi.com/software. And we are going to download and install the Raspberry Pi imager here. So what is this? This is actually a software you can install on Windows, macOS and also Linux. And this will allow you to easily flash the operating system, so the Raspberry Pi operating system, into your SD card. So click on whatever operating system you have right now. Okay, I am running Windows, so I'm going to download it for Windows. Then you can wait a few seconds. Okay, and when you have the installer, you can just run the installer. Maybe it will ask you to confirm, so I'm clicking on yes if you have a pop-up on Windows. And then, well, let's install the Raspberry Pi imager on the computer. So click on install, and that's pretty much it. So now you wait a bit. Okay, and let's finish. So you can run it directly or not. So let's finish the installation. And if you want to run it, well, you can just go on the Windows button here or just press the Windows key and search for Raspberry Pi, and you will find the Raspberry Pi imager here on the applications. So if you have another pop-up, you click on yes to allow the software to run on Windows, and then you will get this software here. So make sure that here I have version 1.7. Okay, make sure that you have at least 1.7. It can be a higher version, but no lower than 1.7. So if you already have this installed and it's not 1.7, just remove the software and reinstall it by downloading the latest version. Now, well, what you can do is you can take your micro SD card and put the micro SD card on your computer. So I just did that, and well, maybe you will have some file manager that opens. You can just close everything, and then you're gonna here click on choose operating system, and you're gonna choose the latest operating system here. So the first one on the top. Then you click on choose storage, and it should automatically detect the SD card that you have put. So here I have a 16 gigabyte SD card. So I click on this, and then, well, before you click on write, what we're gonna do is we're gonna click on this settings button, and we are going to configure actually SSH and the Wi-Fi and a few other things before we write the operating system. And this, again, if you don't have this, is because you maybe have a version that is not 1.7. Okay, so if you have an earlier version, please download the new one because you would not have this option, these settings. So what do we do on this menu? You're gonna click on enable SSH and leave it like this. Okay, we're gonna use SSH to get access to the Raspberry Pi using the terminal, and I'm gonna show you that just a bit later. And from this, we will be able to configure everything, for example, get access to a remote desktop, etc. So you click on enable SSH, and then you have set username and password. So you can keep Pi, okay, this is like the default username for Raspberry Pi. You can keep this or choose anything else. And I'm gonna keep Pi, and then you set a password. So just any password you want. This is going to be the password for the user named Pi. Okay, so make sure that you, of course, type the correct password and that you remember it. And then you go down and you're gonna configure the Wi-Fi connection. And so here, well, if you are already connected, so I'm gonna check here, and you can see that my computer is already connected to a network, so a Wi-Fi network called Your Wi-Fi Network. So this is actually a hotspot I have made from my phone, okay, and I have named it Your Wi-Fi Network, so it's easier for this lesson. And if you look at show password, so it should automatically put the name, so the SSID and the password. So I have set Your Wi-Fi Network as the name and your password as the password. So of course, make sure that you use the correct Wi-Fi name and the correct password, because that's not going to be the same for you. Okay, so make sure you use the same one that your computer is connected to. That's super, super important, because if your computer and your Raspberry Pi are not connected to the same Wi-Fi network, then they won't be able to find each other. Okay, so once you have configured the Wi-Fi, you go down, and then you're gonna also do this set local settings. And so you can choose your time zone. So for me, it's Europe, Paris for France, and then a keyboard layout. So if you have a QWERTY keyboard, you keep US, but for me, I'm gonna go to FR because I have a French keyboard. So make sure that you use the keyboard layout that corresponds to your actual keyboard. And then that's pretty much it. So to recap, we have enable SSH, set username and password with a custom password here and username Pi, and then click on setup, so configure Wi-Fi, put the correct name and password, the same as your computer is connected to, and then set local with the time zone and the keyboard layout. You can click on save, and then all you need to do is click on write, and you have a pop-up here. All existing data will be erased. Okay, so make sure that what you had previously on the SD card is not something you want to keep, because that's gonna be completely erased and the operating system is gonna take all the space on the SD card. So are you sure you want to continue? Yes. And then you can wait. So that's gonna take a few minutes, okay, to write the operating system on the SD card. Okay, and after a few minutes, you should see this pop-up, write successful, which means that the Raspberry Pi operating system has been downloaded, has been written to your SD card, and everything worked correctly. So you can click on continue, and now, well, congratulations, you have installed Raspberry Pi operating system on the SD card. On boot, your Raspberry Pi should automatically try to connect to the Wi-Fi network you've provided. And also SSH will be automatically enabled, which will help us in the next step. So now what we are going to do is to boot the Raspberry Pi. And before you do that, make sure that the Raspberry Pi is powered off, okay, and that nothing is connected to it. No cable, nothing. This is very important. So you can take the SD card out of your computer and just plug it to the SD card slot of the Raspberry Pi, just like you see on the photo. Then once the SD card is correctly plugged, you can power it on. Okay, and to power on the Raspberry Pi, make sure that you use a good power supply with at least 5 volt and 2 amps. Okay, you can use an official Raspberry Pi adapter or even a recent phone charger. One thing to make sure is don't power your Raspberry Pi from the laptop directly. Okay, the current may be too low and you will have some problems later on. So when you boot the Raspberry Pi, you will see first a red LED powered on, and then the green LED should blink randomly. If the blink LED blinks randomly, this is actually a good sign. It means that the Raspberry Pi is booting. And after a few seconds, maybe 1 or 2 minutes stop, the Raspberry Pi should be connected to your Wi-Fi network, and this is where we're gonna go to the next step and find the Raspberry Pi IP address on the network. What is the current state now? You have this computer right here that is connected to the Wi-Fi network. So here for me, it's your Wi-Fi network. Then you have also the Raspberry Pi, which has boot and is connected to the Wi-Fi network. But to be able to connect to it, you need to know what is the Raspberry Pi IP address. So first, how to find the Raspberry Pi IP address. So there are many ways to do this, but one way is to use a software that's gonna scan the network and find the IP addresses on the network. And the one I'm gonna use here is Angry IP Scanner, okay? And why I use it? Because it's multi-platform. You can use it on Windows, macOS, and also Linux. So you just type Angry IP Scanner and you go to here angryip.org. You can go to Downloads, and then you can see you have either the Windows version, the macOS, or Linux. So here, of course, I'm on Windows, so I'm gonna click here on Windows Installer. But before, let's see quickly on macOS. So if you are on macOS, you will need to install the Angry IP Scanner bundle here, and then right-click and open. Okay, and before that, you will make sure that you have Java installed, and so you can click on Java here. And well, this is going to install Java, so you can click on Download Now and just select, well, the version you have, so macOS. This is the same if you are using Linux, okay? So you can just download with the current version you have, standard JDK, and just download from here and install it. And the same for Linux. And now that you have Java, you can so click here, or on Linux, you can also download the package that you want. If you are on Windows, it's even better because the installer already includes Java runtime, so you don't even need to install Java on the side. So I'm gonna click on Windows Installer, and then you wait that the download is finished, and you can click on the installer. So maybe you have a pop-up, you click on yes, you click on next, and then you just choose the path, or you just leave it like this and click on install and just wait a few seconds. All right, now you click on finish and you can just search on the Windows bar or on the application menu for Angry IP Scanner. You launch it and okay, you click on next, 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 and close. Well, that doesn't really matter. And so you will have this interface. And once again, before I even start to do anything here, go back to Wi-Fi settings and make sure that your computer is on the same Wi-Fi network that you have set for your Raspberry Pi. This is super, super important because if you're not on the same network, you just can't find the Raspberry Pi. And now let's see how to configure this so we can find the Raspberry Pi IP address. So what do we have here? We will be able to scan, when we click on the start button, to scan a range in the network, so in the Wi-Fi network, and we're gonna have different IPs, the ping, the hostname, etc. So the IP address will be all the IP address that we try, and then if we find something, so if there is a host, okay, if there is, for example, a laptop or a Raspberry Pi or anything else, we will find it and we will have a ping, which means like how long did it take to ping or to get access to the host, and then you have the host name, so that can be Raspberry Pi, that can be your laptop name, etc. The thing is that with Raspberry Pi, sometimes here with Angry IP Scanner, you will not see host name, so we will click on this icon here, and on the right, you will look for Mac vendor, and click on the left button to add it, and click on OK. So now we have Mac vendor. So that will allow us to know for sure that we have found the Raspberry Pi. Okay, so the next thing to do is, so here we have host name. You can see this is the host name that corresponds to this computer right here. Okay, so for you it's gonna be different, of course. And then you click on IP here. And well, you may have just a few or a lot. It depends. For me, I have a lot of things because I have some virtual machines running, but you will find something like Wi-Fi. So maybe it's not the same thing, but find a line that looks like Wi-Fi and that has an address like this that starts by 192.168. Okay, if you have this, then that's a good start. You may also have something that starts with 10.0. Okay, that's also valid. That's like a local network. And so, well, try to find the line that corresponds to what I have here on my computer. So I click on this. And then you can see the IP range now is 192.168.31.0 to, well, the same first three numbers and 255. So if you don't have this, you just delete and you put 0 at the end, and here you put 255. Okay, so the first three numbers actually correspond to the network, okay? So the current network has a name but also has an IP address, which is 192.168.31. And then all the addresses here in the network. And you have actually 256 possibilities from 0 to 255. Actually, this one is the network when it finishes with 0, and 255 is called also the broadcast address. And so what it's going to do, it's going to scan everything between the 0 and 255, and the Raspberry Pi should, of course, be somewhere between those two IP addresses in this network. So once you have this, and of course that the Raspberry Pi has already boot, so make sure that you have boot the Raspberry Pi for at least 1 or 2 minutes for the first boot, because it can take some time to connect to your Wi-Fi network. Then you can click on Start, and you're going to wait for a few seconds. Okay, if you have that kind of alert, you click on Allow Access, of course. Okay, and you can see scanning completed in 37 seconds, so it can take more or less time, it depends. Well, you click on Close, and then, well, so if it's red, it means that nothing has been found. If it's blue, something has been found. But let's actually click on Ping and sort by ping. Okay, and you can see that, well, we have the Raspberry Pi here. So what happened here is that we found 3 IP addresses, okay? This one corresponds to actually this computer, so of course it's gonna be found. And then we have something else here and something else here. And you can see we have a host name, raspberrypi.local, and we also have Mac vendor Raspberry Pi trading. So if you find one of those two, you know that you have found the Raspberry Pi. And what is the IP address of the Raspberry Pi? Well, this is the IP address here. So for me, that's 192.168.31.76. And of course, it's going to be different for you. What we can do now is to use SSH to take control over the Raspberry Pi and really get access to it. And the first thing you can do is open a file manager, okay, and go to your users. So I'm going to go to users and then my user, okay. Here, you may find a folder named .ssh. So if you don't have all the dot folders, those are actually hidden folders. So you can go on View, Show, and then Hidden Items. Make sure that you check that box. And so you can find the .ssh. If you can still see all the other dots, so maybe not the same as me, but if you can find other hidden folders here, but not the .ssh, then that's fine. You don't need to do anything. But if you see the .ssh, you go here, and you may have a known host file. So maybe yes, maybe not. But if you have one, you're gonna just delete it. Okay, that step is just in case we have some trouble connecting. And now, well, you can close the file manager and you can open a terminal. So how to open a terminal, or in other words, the command line tool on Windows? Well, you just open the Windows menu here and you can type CMD, for example, and you can open command prompt and you will get something like this. So I will zoom in with Control and the mouse here. Great. Just a bit more. And if you are on macOS, you can also search for command line. And if you are on Linux, well, I probably guess that if you're on Linux, you know how to open a terminal. So once you have the terminal, whether it is macOS, Linux, or Windows, you have the SSH command. So if you just type SSH and you press enter, you should have something like this. Usage SSH. So basically that's kind of a help for SSH. If you don't have this, okay, if you have SSH command not found or something like that on Windows, well, you can go on a web browser and you can search for Putty, so P-U-T-T-Y, and this is an SSH client, okay, that you can download. So you can just download Okay, so you download the installer here and you just install it, and you can then use it to connect to SSH to the Raspberry Pi using a graphical interface. But this is just in case that SSH doesn't work on your Windows. For example, if you have an old version of Windows that is lower than Windows 10, you will not have SSH by default. Alright, so coming back to the terminal, how do we get access to the Raspberry Pi? Well, you will put the SSH command and then space, and then you need to provide the username with which you want to connect to the Pi. And so what is the username? Well, if you remember in the lesson where we actually flashed the operating system into the SD card, we had to specify a username and a password. And the username I have specified was Pi. So if you have provided a different username, make sure you use the different username here. Okay? So you put the username and then you put @ and then we need to put the IP address. So what is the IP address? Well, the IP address is the one you have found here with Angry IP Scanner. So 192.168.31.76. So I put it here, 192.168.31.76. And make sure that you double check that this is the same that you are using here. So once you have this SSH space username @ IP address, you can press enter. And you will see this. So are you sure you want to continue? Yes, no. So you just type yes and you press enter. And now you can see that it's asking for the password. And so what is the password? Well, the password is the one you have provided also when you were flashing the operating system. So you had to provide a username, which was Pi or something else, and you had to provide a password. So here you're gonna type the exact same password. And this is very important. If the password doesn't work here and you get a password denied or something like this, it's just because you have put a wrong password during the installation. So you need to go back to flashing the SD card and make sure that you use the correct password. So I press enter. Okay, you should not see, when you type the password, you should not see anything. You just type the password and you press enter. And now you can see if you've put the correct password, now we are actually in the Raspberry Pi. So we are still in the terminal, but the terminal is now connected to the Raspberry Pi via SSH, and we are actually inside the Pi, so we have access to the Raspberry Pi. And you can see here we have the user Pi, and the host is also named Raspberry Pi. Welcome back to episode number 3 of this tutorial series on Raspberry Pi for complete beginners. Let's now install and configure VNC. VNC will simply allow you to use the Raspberry Pi desktop from your own computer. And this is great, so you don't need to only use the terminal with command lines, and you also don't need to have a monitor plugged to your Pi. Even if you have a monitor, you will see that it's much more convenient to work without it and to work just from your computer with a remote connection. And the reason why we have set up SSH just before is simply because we need to access the Raspberry Pi through SSH so we can set up VNC. So how to set up VNC? Well, first make sure that you are connected to the Raspberry Pi, so you should have something like this in the command line. Note that you can exit SSH by typing here exit and press enter, and now you can see I am back to the terminal on Windows. So I will type the command again, SSH Pi at the IP address I have found before, 192.168.31.76. So make sure that you use the same username you've put during the installation, and make sure you use the IP address that you have found before. Then I put the password, and so make sure you've put the password you have also put during the installation. All right, and I'm back to the Raspberry Pi. Now what I will do is I will do sudo space raspi-config. What does it mean? Well, it means I'm gonna open the configuration of the Raspberry Pi, and sudo is here to get the admin rights, so the administrator privileges. So you type this exactly and then you press enter, and you will have something like this. So you will have a menu that looks like this. And so you can navigate in this menu using the arrows from the keyboard, okay? Up and down, you can see, and right to go to select and finish. Okay, and left to come back here to the menu. And we are going to go first on interface options and then on VNC. So you find interface, VNC, you press enter to validate. And then you can see, would you like the VNC server to be enabled? So I'm gonna go on yes and press enter. Okay, the VNC server is enabled. I also press enter, and then I'm gonna go with the right arrow to go to finish. I press enter, and now VNC is enabled. And what I'm gonna do now is I'm gonna reboot the Raspberry Pi. So I will do sudo and then space reboot, and then I press enter. And when I do this, the Raspberry Pi is gonna reboot. And now if you can see, if I press enter, well, the command line is not answering. It is a bit stuck. So you will wait until the command line is not stuck anymore. It means that the Raspberry Pi has reboot and that you can connect to it again. Okay, so you can see now the connection has been reset. So maybe you need to wait a bit more, let's say 20 seconds to 1 minute. Okay, so if you can't connect back to the Raspberry Pi, wait a bit more. Maybe it needs time to boot, connect to the Wi-Fi, and be ready to accept an SSH connection. Okay, so now I think enough time has passed. What I'm gonna do here, I'm not gonna type the command again, I'm just gonna use the up arrow, okay, to go back to the previous command. And I'm gonna press enter, and I'm gonna put the password. And I am back to the Raspberry Pi. So I'm gonna type again sudo raspi config with a dash here, and then press enter, and I am back to this menu. So enabling VNC is not the only thing we need to do. There are just a few more steps so that everything will work fine. So now you can go on system options, so you just press enter here, go to boot auto login, press enter, go to desktop auto login. So by default, maybe it's going to be console login, which means you don't have the desktop enabled. You can choose desktop so that you can boot on the graphical desktop, because if you try to get access to the desktop with VNC and the desktop is not enabled, well, that's not gonna work. So you can choose desktop or even desktop auto login, which will make sure that you directly get access to the desktop. You don't need to log in before. And that's the one I'm gonna choose here for simplicity. So you press enter here. Okay, and then you go right arrow, finish. And you can see here, it's asking you directly, would you like to reboot now? So let's do yes again, and let's wait a few more seconds. Okay, and if it still hangs here, okay, if it doesn't go back to this line, you can also try to press enter a few times until you have this connection reset. Now the Raspberry Pi should have boot again, so let's just use the up arrow to connect to it again. Let's put the password. And then in the Raspberry Pi, we can also use the up arrow to get to the last command, which was sudo raspi config. If you use up, we can also use reboot. So just go up until you find the raspi config command, you press enter and back to the menu. This is going to be the last step here. We are going to go to display options and then resolution. So either resolution or VNC resolution. So you find this, you press enter, and well, the thing is that there is a default resolution that maybe will pose some problems, and you will not be able to get access to the desktop for some weird reasons, right? So basically what you need to do is to set up a resolution manually by yourself by choosing one of those resolutions. So which one to choose? Well, actually, I would recommend to choose the resolution that is closer to the resolution you currently have on your computer screen. Okay, so for me, I have a full HD, so that's gonna be 1080p. So I'm gonna choose that one. So I press enter. Okay, so now the resolution is set to that, and then go back to finish. And you need to reboot again, so let's press yes again, and let's wait a few more seconds. Okay, and now the Raspberry Pi has reboot again. And we don't need the command line anymore. So we have set those three options in the raspi config menu. Now we can connect to the remote desktop. And how to connect to the remote desktop with VNC? Well, we will need a VNC client on our computer. So to do that, you will go to a web browser and you will just search for, so you can search for that, VNC viewer, real VNC. So real VNC is the name, okay, it's the name of the software. We're going to use that one. So you can go here, download VNC for Windows. Okay, so you can actually click on Windows, but you also have macOS and Linux. And so if you want the URL, it's here, realvnc.com/en/connect/download and then /viewer/Windows. And here, well, so if you're on Windows, you click on Windows. If you're on macOS, you click on macOS. On Linux, and then you can see we have also a Raspberry Pi. But don't click on Raspberry Pi, don't download for Raspberry Pi, because what we're gonna do here is we're gonna install a client. So the client is from where we try to connect. Okay, here I'm trying to connect from Windows to the Raspberry Pi. If I was to connect from another Raspberry Pi to this Raspberry Pi, I would choose Raspberry Pi as a client. Okay, but now the client is actually the computer here. So this computer we are using right now. So if you have Windows, you click on Windows and just download VNC Viewer. So you wait a few seconds and then you can launch the executable. Okay, select the language. Okay, next, accept the license, next, go to next and then install. Maybe you have a pop-up, you click on yes, and then the installation is finished. Okay, and back to the desktop, you can go to Windows button or the application and search for VNC Viewer. Here you can click and open the VNC Viewer app. So let's remove that. And now, well, you can go on File, New Connection. And here you will need to put the IP address of the Raspberry Pi. And so once again, make sure that your computer is connected to the same Wi-Fi as the Raspberry Pi. Okay, make sure you have not changed the Wi-Fi on the computer. And so the IP address for me was 192.168.31.76. I'm gonna put a name. This doesn't really matter here, just name. I'm gonna put Raspberry Pi, and then you can just leave everything like this. Okay, and then you simply double click. Okay, it may ask you to confirm that you want to continue. And then you need to put a username and a password. So the username for me was Pi. So you put the same username as you've put before to connect to SSH and the same password. Then if you want, you can also click on remember password. So it's not gonna ask you every time. And just if you ever modify the password on the Raspberry Pi, you will have an error trying to connect and you will need to provide the new password. So I click on OK. And well, what is this? That's the Raspberry Pi desktop. You are now connected to your Raspberry Pi and you have access to the desktop. So you can use the Raspberry Pi as a normal computer directly, remotely from your own computer. And we are going to finish the configuration. So just a few last steps before you can use the Raspberry Pi. So you can also go here and select full screen, and now I am full screen on the Raspberry Pi. What I am going to do is I'm going to click on the Raspberry icon here, and this will open the menu. So you can see the menu bar is actually on top. Okay, on Windows it's at the bottom, maybe on Ubuntu it's on the left. Well, here it's on top. You will go to Preferences, and then I'm gonna go to Appearance Settings first. Okay, this is optional, but this will allow me to have, so if I go to Taskbar, I will put a larger taskbar. Okay, you can see it's a bit bigger for you to see in the course. So if you want it to be bigger, you can just change the icons here or maybe put it smaller, okay, as you wish. Then you can also put it at the bottom. I'm gonna leave it at the top. I'm gonna go to System, and the font is actually 12. So you can change the font if you want. I'm just gonna put the font to 16 so you can easily read when I do stuff on the Raspberry Pi. But you can keep it like it was before. Okay, and then that's pretty much it. I click on OK, and now let's finish the configuration. So you click here, you go to Preferences, and then Raspberry Pi configuration here. So a few things that you have to know. So you have first on system the password. Okay, so you can change the password if you want. You can go here, change the password, and then you will reboot. And when you reboot with VNC, you will need to provide, of course, the new password. And make sure that also the boot to desktop is always checked here. Then on display, you can change the resolution of VNC. Okay. On interfaces, you can see that we have SSH and VNC that are already enabled. So we enable those from the terminal, but you can also enable and disable from the graphical interface. And here, of course, I recommend that you leave them enabled all the time. And then you can go to localization and set the local if you don't have set the local before when flashing the operating system, the time zone, and also the keyboard. So if you have noticed that the keyboard layout doesn't correspond to your current keyboard, well, set the new keyboard here. Then you click on OK, and it's done. You can also now check the Wi-Fi. So here I am connected to the Wi-Fi network named Your Wi-Fi Network, which is the one I use for this course. So if you click here, you can also choose a different network to connect to. And so note here that if you choose a different network to connect to, you will need to find the IP address again. So you will need to connect your computer to the same network as the Raspberry Pi, go to Angry IP Scanner, find the IP address again, and then connect back to the Raspberry Pi with VNC or even SSH if you want to. All right. And the last thing I am going to do here is I'm going to update the software. So Raspberry Pi OS, you have the operating system, but you have also a bunch of software and applications that are installed on top of the operating system. And even if you just installed it now, maybe not everything is up to date. And it's always good to have up-to-date softwares. So you can click on this icon here and install updates. It's going to fetch the new update, comparing the versions, and then install the update. So this can take quite a long time. It depends on your internet connection speed also, because it's gonna download the new packages and install those. So you can wait a few minutes here. Okay, and when you see this, you can click on OK, or it's just gonna disappear. And now one very important thing before we finish this installation section is that how to actually power off the Raspberry Pi. Well, like your computer, you don't just switch off the power on your computer. You first shut it down properly using the menu, and then you remove the power. Okay? If you just remove the power like that on the Raspberry Pi, well, this may lead to some problems. For example, your SD card could be corrupted, and the next time you boot, it's not gonna work. So how to power off the Raspberry Pi? You go here on the menu, and you click on Shutdown. Okay, and then you can click here on Shutdown. After you click on Shutdown, the Raspberry Pi is gonna shut down. So let's do this. If you are on VNC, you're gonna lose the connection. You can see now we lost the connection. And then you wait maybe half a minute, up to 1 minute, and the Raspberry Pi should be completely shut down. So the physical green light on the Raspberry Pi board should not blink anymore, and the red light, of course, is still on because that's the power. And now you can remove the power supply. And then when you want to boot the Raspberry Pi again, you make sure that you have the SD card connected first, and then you plug the power supply cable. And well, great, you have now successfully installed Raspberry Pi operating system. Hey, I hope you're learning a lot, and I also hope you like this tutorial. If you find it useful, then you can check out the full course named Raspberry Pi for Beginners, which actually contains 10 hours of hands-on video lessons. I will leave a link in the description if you are interested. Alright, and let's continue with the video. Welcome back. This is episode number 4 of this tutorial series on Raspberry Pi for complete beginners. From this tutorial and going forward, you are going to learn how to use and program the GPIOs of your Raspberry Pi board. Using GPIOs is a great way to make your Raspberry Pi control simple hardware components like LEDs and push buttons. And to be able to create a hardware circuits with Raspberry Pi, you have to know just a bit about breadboards and resistors. That's what I will explain in this video. First of all, let's see how to use a breadboard. A breadboard is very useful. You will use it to connect multiple components together and with your Raspberry Pi GPIOs. You can plug some wires, resistors, LEDs, well, anything you want, basically, on a breadboard. What you need to know is that underneath the surface, there are some metal lines that make connections between the components. A component that you plug on a line is electrically connected to all of the other components on that line. And here is a representation of the connections, okay, in a breadboard. As you can see here, we have two main lines, okay, on each side of the breadboard. Okay, you have a blue line and a red line. Okay, those are just colors, okay, that are used to indicate that the blue line is for the ground. Okay, this is the minus line, and the plus line in red is for the power supply. Okay. So you will have ground and power supply. Everything in that line is connected. Okay, so whether you plug it here or here or here, it's the same. And it's also valid for the plus line. Everything on that line is connected with all of the other points. And then here you have different points, but those points are connected, as you can see, in that way. So usually you will have 5 different points, plugs, where you can just plug any component, and whether you plug it here, 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 or here, this is the same point. Okay, all of the components plugged here will be plugged to the same point. So you have multiple lines or columns here, okay, and each one is independent. So if you want to plug two components to the same point, then you put them in the same column here. If you want to make them separate, make sure to use a different column. And some of the boards you will only have half of that. Okay, you maybe have only the A section plus the B section, and some of the boards, like the one I use, we have twice this section here, okay, in symmetry right here. So this is the same as this, and the D part is the same as the A part. So as you can see on the breadboard I can find here the plus sign and the minus sign. Okay, so you can see the plus sign, we have the red line. So every dot, okay, on this line, so all the dots on this line are connected together. And then you have the minus line, which is the blue line. So every dot on that line are connected together. Okay, in the image I showed you, the plus was on the inside and the minus was on the outside, but here it's inverted. But actually that really doesn't matter, okay? It's just two lines that are connected together, okay? And you will use the plus for power and the minus for ground. Now, here you can see I have A, B, C, D, E, and I have some numbers here, 1 to 60. So those are actually lines that are connected like that. So for example, line 1, you have A, B, C, D, E, all of the dots A, B, C, D, E are connected together. Then line 2, which is independent, you have all of those 5 dots connected together, okay? And that multiplied by 60 something times, okay? And you have the exact same here, okay? The 5 dots here are connected, etc., etc. And you also have a plus and minus line. Depending on your board, you may only have this side, okay, of the board, which is totally okay. In fact, you can see I could just break it here, or it's modular, so I could change the way it is. And you can also have a shorter board, for example, half this side. Okay, but the important is just that you find the different dots and which dot is connected to which. To make an LED blink, for example, we will need an LED, some wires, but also one resistor. The resistor is here to lower the amount of current that goes through the LEDs, and it's also helping to protect the GPIOs so they don't get burned with too much current. So now, how to recognize a resistor? Maybe the resistors are correctly set per value in the kit you have, but if it's not the case, you will have to read the value from the color bands of the resistors. Here is a table to help you find the value of a resistor with the colors on it. Usually you will see 4 bands or 5 bands resistors. The first 2 or 3 bands correspond to a number. The next number corresponds to the multiplier. For example, multiplied by 1, 10, 100, 1 kilo ohm, 10 kilo ohm, etc. And finally, the last band is for the tolerance or the precision of the resistor. For what we'll do in this course, you will not need to worry about the tolerance. Any value will do. So the first resistor we are going to use is the 1 kilo ohm resistor. 1 kilo or 1000, okay? So you can see with a 4-band resistor, you should have brown and then black, which means 1 and 0, okay? That will make 10, and then multiply by 100 ohm, which is the red color. So 10 multiplies 100 is 1000 ohm. And then the tolerance, you don't need to worry about that, any color will do. And if you have a 5-band resistor, you should have first the brown and then the black and then black, which will make 100, okay? And the multiplier will be brown, so it will be 100 multiplies by 10, which makes also 1000, okay? So you have two ways of computing 1000 here with the 4-band and the 5-band resistor. And the second resistor we're going to use is the 10 kilo ohm resistor. So for the 10 kilo ohm, you will have either a 4-band resistor with brown and black, okay, just like before, but then the multiplier will not be red, the multiplier will be orange, okay, orange for 1000, okay, so 10 times 1000 makes 10 kilo ohm. And if you have a 5-band resistor, then instead of a multiplier which is brown here with 10 ohm, the multiplier will be red with 100 ohm. So you still have brown, black and black for 100, and then you multiply 100 by 100, which makes 10,000. So that are the two resistors you have to find in your kit. If you don't find 1 kilo ohm resistors, you can pick a lower value, for example 330 ohm or 470 ohm, okay? So you can use the table on the left to compute that value. However, I would not recommend going below 330 ohms for the LEDs, okay? 1 kilo ohm is in fact a pretty high value for an LED. With the Raspberry Pi, we could use a lower value, but it's a nice value if you want to connect many LEDs, so the total current consumptions will not be too high and will not go beyond the Raspberry Pi's limit, which is 50 mA. So make sure that if you use a lower value resistor, you don't connect too many LEDs. For example, you don't connect 15 LEDs with low resistors. And then for the 10 kilo ohm, if you don't have 10 kilo ohm, you could guess with a lower value as well. I would not recommend going below 2 kilo ohms for that. And you can use also a higher value, but don't go too far. And basically, to connect components such as LEDs, the higher the resistor's value, the less current you will take, and thus you can plug more LEDs to your circuit while staying safe. Alright, now that you have the color code for the resistors you have to find them in your kit, and after that, let's build that first circuit with an LED. And welcome back to episode number 5 of this tutorial series on Raspberry Pi for complete beginners. So in this tutorial, you are going to create your first circuit. For that, you will need to have your Raspberry Pi board, you will have to have also an LED, a 220 ohm resistor, a breadboard, and some wires. If you are not sure about how to read the resistor's value, then please go back to the previous tutorial in the series. And I'm going to start with a quick note on how to safely manipulate the Raspberry Pi so you can avoid burning it and having to buy a new one. And then we will build the circuit together with the LED and the resistor. Working with the Raspberry Pi GPIOs can be quite dangerous for your board if you don't exactly follow the instructions and if you plug a wire in the wrong place. Note that you don't really risk anything by yourself. The current is too low to get hurt or to hurt anyone. The risk here is to kind of fry your board, and after you fry your Raspberry Pi, you won't be able to use it anymore. So here are a few points that you have to follow and if you carefully follow them, you won't have any problems. First, always power off your Raspberry Pi when you make a change in a circuit, even if it's just disconnecting and reconnecting one single cable. Power off your Pi, remove the power cable, make hardware changes, and then and only then repower on your Raspberry Pi. Second, when the Raspberry Pi is powered on with some hardware components, don't touch the components with your fingers. You may damage your Pi with an electrostatic discharge, also called ESD. And also this is quite obvious, but don't use any metallic tool to touch the hardware setup when it's running, for example a screwdriver. Only bad things can happen if you do that. Third point, before you power on your Raspberry Pi, double or even triple check your hardware setup, even if you're sure about it. Personally, even if I make the simplest hardware setup that I'm sure about, I still double check everything every time. 4. Always start with the ground pins and make sure that the ground is common for all your components. We are going to see that more in details in the next lessons. And finally, GPIO pins support only 3.3 volt. Don't connect anything using 5 volt directly to the GPIO pins, okay? You may burn the GPIO pin. So that is not an exhaustive list, okay? Those are some of the most important points you have to follow, and I will give some more warnings and stuff you have to do in the following lessons. Because just plugging a wrong cable in the wrong pin can destroy your Pi in a fraction of seconds, and then you have to buy a new one. It happened to me in the past and it's not really fun. Of course, I'm not saying that to scare you, I just want to make you extra careful with any hardware setup you will do in the future. If you follow what I do, and if you always double check any setup before booting your Raspberry Pi, then everything will be okay. Alright, and now let's build our first circuit. Let's start our first circuit with the Raspberry Pi. So, first of all, what you can do is put everything you need here on your table. So I will need my breadboard, I will need my Raspberry Pi, okay, and note that I have completely powered off my Raspberry Pi, and also I have removed the SD card here from the SD card slot. Okay, why did I do that? Because the SD card will go a little bit outside of the board, so when you manipulate it, it may happen that you break the SD card. So it's better always to remove the SD card when you're going to manipulate the Raspberry Pi. Then I have two wires. So I have here male to female wires. Okay, so a black one, okay, male, female. Black one that will be used for the ground, and a yellow one or any other color. Just maybe avoid black and red for now, so just take any color you want. And then I have here an LED. Okay, so basic LED. As you can see, the LED has two legs and one of them is shorter. You have a shorter leg, and actually the shorter leg is the negative side of the LED and the longer LED is the positive side of the LED. Okay, so we are going to plug the negative side of the LED to the ground. And then we have a resistor. So this is the 1 kilo ohm resistor. Okay, I have a 5 band resistor. So actually like this. So this is the same as I showed you in the previous lesson. Okay, and the resistor has no sense. Okay, so this is not negative or positive. You can just plug any side on the positive or negative side, it doesn't matter. So now what I'm going to do, I'm going to take my breadboard, and first I am going to plug the, well, before the LED, I'm going first to put the ground. So I take my black wire, the male part, and I put it on the, here, on the blue line. Okay, I could put it here, anywhere on the blue line, just chose to, can put it here, okay, it doesn't matter. It should be just on the blue line. And then I take my LED, okay, I can see here I have the shorter leg, okay, shorter leg, which is that one here. So what I'm going to do is put the shorter leg here to a ground pin, okay, a ground dot. So the shorter leg will be connected to the ground, okay, which is all of that line. And the other leg, actually, I'm going to connect it to another line here. Okay, so the long leg is here connected to line, here it's line 15 or 16, doesn't matter. Okay, and the short leg to the ground. And now I'm going to connect the ground, so this wire, to the ground of the Raspberry Pi. And as you can see here on the image I'm going to provide on the side, you have to go from, so you have two columns here. You have the first one on the inside and the second one on the outside. And we are going to use mostly the one from the inside, okay, so that will be more convenient. And you have to count until 5. So 1, 2, 3, 4, 5. So you're going to plug the black wire on the 5th GPIO here. Okay, you can see on the 5th pin. 1, 2, 3, 4, 5. This is important because if you miss that one, then you are not connected to the ground, okay? The 4th one is not the ground and the 6th one is not the ground, only the 5th one, okay? So now your ground is connected. So you have the ground on the Raspberry Pi, the ground on the breadboard, which is connected to the shorter leg of the LED, which is the negative side. Now what I'm going to do is I'm going to take a resistor, so the 1 kilo ohm resistor, and I'm going to plug it one side connected to the longer lead of the LED. Okay, as you can see here, it's on the same line. So this dot and this dot are connected together. And I'm just going to put it here on another line, not too far away. Okay, so you can see I have put one side of the resistor in the same line as the LED, the long leg, and one side on another here, another dot. And now the final step is simply what I'm going to do. Maybe I'm going to use it like this. And what I'm going to do is I'm going to put another, so the yellow wire here, the male, into here. Okay, so on the same line as the resistor here. And now the female connector, I'm going to put it just after the ground one. So it should be on the 6th pin from the top, okay, and on the inside side of the Raspberry Pi. So 1, 2, 3, 4, 5, you have the ground, and 1, 2, 3, 4, 5, 6, you have the wire which is connected to the resistor here, okay? So once you have correctly plugged the ground, the rest is easy because it's just the following one of the inside. And now the setup is finished, so to double check it, we can simply see that, okay, first let's check the ground. We have the ground here which is going there. Then we have the ground which is connected to the shorter leg of the LED, which is the negative side. Then it goes through the LED, the long leg, which is the positive side, and then it's connected to one side of the resistor here. The resistor is then connected to that dot, and we have the yellow wire which is connected to the other side of the resistor, and then coming back to this GPIO. So the setup is now finished. So what you can do next is, once you are sure that everything is correct, you can put back the SD card here, okay, put it on a flat surface, put back the SD card, and then you can power on the Raspberry Pi. Welcome back to episode number 6 of this tutorial series on Raspberry Pi for complete beginners. In this quick episode, you will learn about the GPIO panel on the Raspberry Pi and how the GPIOs work. This quick overview will be super useful for the following. Here is the complete pinout for the Raspberry Pi 4, but it's also the same as for the Raspberry Pi 3 and the Raspberry Pi 2. The GPIOs haven't changed with the latest evolutions of the Pi. So, as you can see, we have some pins in black which represent the ground. All those pins are connected together. Then we have what we call power pins, 2 pins for 3.3 volts and 2 pins for 5 volts. And then the GPIOs in orange. Each GPIO has a number, and that's the number you will use in your Python code to interact with the GPIO. Quick reminder here, the GPIOs are 3.3 volt pins and not 5 volt pins. That is very important. So now, how to control a GPIO? Well, it's pretty simple. You first have to set up the GPIO either as an input pin or as an output pin. You will use input when you want to read data, for example, with a push button, and you will use output when you want to write data, for example, with an LED. Once you have set the mode of the GPIO, you can use the GPIO. If it is set as input, you can read a value, and the value has only 2 states, high and low. High and low correspond to the voltage which was read from the pin. If the voltage is high enough and close to 3.3 volt, then the value that you will read will be high. Otherwise, it will be low. And if you have set the GPIO as output, you can write a value, high or low. For an LED, if you want to power on the LED, you will set the GPIO state as high, and if you want to power off the LED, you will set the GPIO state as low. Now, if we come back to the Raspberry Pi pinout image, you can see that the GPIOs are not set in any specific order and some numbers are missing. That is totally okay and it is nothing to worry about, but you will just have to be extra careful when finding the GPIO number corresponding to the pin number. As you can see, we also have 2 reserved pins in gray that you should not use, and 2 pins in green that can be used for UART communication, which we will not cover in this course. Some of the pins can also have an alternate function. For example, GPIOs 2 and 3 can also be used for I2C communication, and the one with the pink label for the SPI communication. Again, that's more advanced stuff, and we will stick with standard GPIO functions for now. And welcome back to episode number 7 of this tutorial series on Raspberry Pi for complete beginners. In the last tutorial, we built a circuit with an LED and a resistor. Let's now see how to use the LED from the Raspberry Pi using Python code. Now that we have correctly set up the hardware for the LED, you can now put the SD card into the Raspberry Pi, you can power on the Raspberry Pi, and then you can connect to it again using VNC, for example, like I'm doing here, or using directly a monitor. And open the Thony IDE here, okay, like here with programming and Thony Python IDE. And now we are going to make that LED blink. So using Python, how can we actually use the GPIOs? Or can we actually put a mode to a GPIO, and how can we actually set states high and low? So we are going first to do import, okay, rpi.gpio. So R and P uppercase, I lowercase, dot GPIO. So that is the module we are going to use. And actually, because the name here is quite long, okay, we don't want to use that name every time. What we can do is use as, and let's put another name, GPIO. So we import that module as that name. So when we use GPIO, in fact, we are using that module here, okay? And the first thing we need to do is actually to do GPIO.setMode, okay, to set the mode for the entire GPIO pins, okay, because there are actually different ways to name the pins and to put number on the pins. So if we don't set the mode, maybe when we call, for example, GPIO 17, then it's not GPIO 17 that will be called, but another pin. So to be sure that we use the GPIO numbers, like you can see here on the screen, we are going to do GPIO.setMode and inside GPIO.BCM. So GPIO setMode, GPIO BCM should be the first thing you do, okay, after you import the GPIO module. And then we are going to do the last line first is GPIO.cleanup. Okay, this will clean up all of the GPIOs. So if you set specific modes for GPIOs, then everything will be back to what it is in the default mode, okay, which can also prevent damages done in your board later on. So for now, our program has 3 lines. Okay, we import GPIO module, we set the mode for the GPIOs, and we clean up the GPIOs, and all of the code we are going to write now will be between those 2 lines here. And now we can actually set up our LED. So first, let's create a LED pin variable, okay, which will be here 17. As you can see on the screen, we use GPIO 17. So I'm using a variable here because we are going to use that number 17 multiple times in our program. Okay, so by using a variable, you just need to use LED pin. And then if you ever want to change the pin or use a different LED, then you just need to change the number here and everything will be updated in your program. So now I'm going to do GPIO.setup. Okay, and the first argument will be the pin number, so LED pin, which is 17, the GPIO 17 because we use the GPIO BCM mode. And then I'm going to do GPIO.out. Okay, so you can have GPIO.in for input pins and out for output. So we just set up the GPIO 17 and we say that this is an output pin. So we want to write to that pin, okay? We don't want to read from that pin, we want to write to that pin. Actually, what I can do here is maybe put the variables here on the top of the program. Okay, and then I'm going to do, so the LED is set up, the GPIO is set up, but the LED will not be powered on. And actually now to power on the LED, what I can do is GPIO.output. Okay, I give the pin, so the GPIO number, and then I give a state, so either GPIO low or GPIO high. GPIO high will basically power on the LED. So because I have set up the LED to GPIO out, now I can use the output on it. So what's happening here is first we set up the GPIO to output, then we power on the LED, and because we do nothing else, then the line 11 will be executed. So all GPIOs will be cleaned up, which means that the LED will be powered off and the pin, so the GPIO 17 here, will go back to its default state. So what we can do here is actually do time.sleep 1, okay, so we can wait 1 second before the GPIO cleanup is happening. And because we use time, we also need to import time, okay, import time. Because this is a module, we need to import the module so we can use it. If you don't import time, you will get an error on this line. Okay, so now we can do, for example, GPIO output LED pin with GPIO low. Okay, and actually let's run that script. So let's name it LED. Okay, and you can see the LED is powered on for exactly 1 second and then is powered off. So this line actually here is not necessary because the GPIO cleanup will do that for you. Okay, just to show you that you can toggle the LED between high and low. So if you want to toggle the LED multiple times, for example, you can do time.sleep1 and then you can put it back to high and then time.sleep1, and that will make the LED blink twice. Okay, let's do it again. Okay, as you can see, the LED blinks twice, and you can continue like that, but of course, as you can see, we are not going to use that structure if we want to make the LED blink a longer time. What we can do instead is, so we have set up the LED. What we are going to do is while true. So we are going to create a while loop, and inside that loop, we are going to use that code here. So what you can do is just select the code and press tab. That will add an indentation. I'm going to remove that. So while true, we are going to put the GPIO high, so power on the LED, sleep 1 second, and then power off the LED, sleep 1 second, and then we go back to line 10 and we continue. This is an infinite loop that will continue to power on and power off the LED. Okay, we can run that script now. And as you can see, the LED is blinking. Great. And now if you want to stop the script, you can just here click on stop. And as you can see, when I run it again, I have a warning. Okay, but the program is still continuing. Why do I have this warning? Is because when we actually killed the program here, when it was in the while loop, the program didn't have the chance to go to line 17 and to clean up the GPIOs. So you will have this error. For example, this channel is already in use, and only because you didn't clean up the GPIO the last time you used them. So actually with this program, this line won't be executed, and we are going to leave it like that. And we are going to solve that problem in a later lesson in a following section. Okay, so to recap, you first import some modules, okay, so you can use them. You create a variable to store the pin number, or here the GPIO number. You set the GPIO mode to BCM, so you can use GPIO numbers in your code. Then you set up the LED pin to output, and then you can actually use a while loop to blink the LED between high and low states. If you already used Arduino before, well, you can see the similarity with an Arduino program, and this is basically the same thing as the blink LED example you can have on your Arduino, just this time written in Python code with the RPI GPIO module and with the Raspberry Pi. Welcome back, this is episode number 8 of this tutorial series on Raspberry Pi for complete beginners. I'm going to show you how to add a push button to your hardware setup. And before you actually do that, make sure that your Raspberry Pi is correctly shut down. So you go here, you click on logout and shut down. Okay, so here is the VNC, and you can see the VNC server is down, so the client can't connect to it. So it means the Raspberry Pi is shutting down. Okay, and now that you have shut down your Raspberry Pi through the software, so you should see here the LED, the green LED should not be blinking anymore, so you can wait maybe 20 seconds, should be enough. Now you can remove the power cable. So now the Raspberry Pi is not powered on anymore. Okay, there is no power. So now you can manipulate your circuit. And what I'm going to do, I'm going to remove also the SD card, so we don't take the risk to break it when we manipulate the Raspberry Pi. I'm going to put it right here, and we are going to put it back at the end. So we have our circuit, which already contains the LED, okay, from the previous example. And now I'm going to add those components here for the push button. So you can see the push button here. I have 4 different legs, okay. I'm going to need to use 2 resistors. So that one here is a 10 kilo ohm resistor, and that one here is a 1 kilo ohm resistor. That you already used that before for the LED, so that is the same model. And then I'm going to use 3 different cables, so 3 wires. I'm going to use 1 male to male wire, okay. You can take a red one, 1 male to female wire, also it's better if you have a red one, and another male to female wire. Just take any color you want and maybe avoid red and black, because we are going to keep red for power and black for ground. Great, so you have all those components. What I'm going to do is I take the push button, I take my circuit here, try not to remove any cable from anywhere, and I'm going to put that on the right of the breadboard here. And as you can see, if I connect the push button like this, if you remember how the breadboard works, well, you can see that this line here, all the dots are connected together. So it means that the 2 legs of the button are connected with each other, and those 2 legs here are also connected with each other. So what we want to do is to put the button between the 2 parts of the breadboard like this. Okay, so each leg has its own dots and its own line, and each leg is independent. Great, so now the first thing we are going to do is to connect one of the legs to the ground, and actually to do that we are not going to directly connect to the ground of the Raspberry Pi, we are going to connect to the blue line here, because you can see we already have a black wire between the ground of the Raspberry Pi and the ground of the breadboard. So I'm going to put the 10 kilo ohm resistor here. One leg will go, so I take one leg and I put it with one leg of the button here, and another leg with the ground like this. Okay, so you have one leg connected to one leg of the button, the other leg to the dot here, which is in the blue line. Okay, that's it for the ground. Now I'm going to need to connect the button to the power, so to 3.3 volt. So that is something we didn't need to do with the LED, we just connected the other side to GPIO directly. And now before we actually use GPIO on this button, we need to power it with the 3.3 power on the Raspberry Pi. So the 3.3 power, you can get it here. So I'm going to take my male to female wire, okay? I take my female connector and I put it here on the very first pin on the inside, okay, of the Raspberry Pi, like that, you can see here. So the very first pin. That one, as you can see on the image, that one is 3.3 volt. And actually I'm going to plug it here in the plus line, okay? Because as for now we didn't have anything connected to the plus line. Now we have the 3.3 volt connected to the plus line. So what we can do is simply to connect one of the other leg of the push button, okay, to the plus line here. Any pin from the plus line will do. So let's use that one. So we could have connected directly this leg of the button to this 3.3 pin actually, but we didn't do that. Why? Simply because now we will be able to connect more elements. So if we have more elements, more push buttons, etc., we can directly connect the power leg to this line here. So just as we have for the ground, we have one common line for everything we need to power on. Great. So the button is connected to ground and to the 3.3 line. And now finally we can actually connect the button to a GPIO. And I'm going to use the 1 kilo ohm resistor here. And I'm going to use another leg of the button. Let's say that one here, that one on the top. And I'm going to connect another leg to another line, okay, totally different line. Okay, like this. Make sure the resistor doesn't touch anything else, okay? So you can see one leg of the 1 kilo ohm resistor is connected here. The other leg is connected to a different line. And now I'm finally going to take my blue wire, so male to female wire here. I connect the male connector here with the resistor. So on the same line, make sure it's on the same line. And the other side of the wire, so the female part, I'm going to connect it to GPIO number 26. Okay, so GPIO number 26 is actually right there. So it is the second to last pin here, if you can see, the second to last pin on the inside, okay, on the internal side of the Raspberry Pi. Okay, make sure you don't connect to the last pin because the last pin is also a ground pin, so you don't want to connect that GPIO to the ground pin. And now the hardware setup is finished. So we haven't changed anything with the LED, but as you can see on the button we have one leg connected to the plus, one leg connected to minus, so to the ground with the 10 kilo ohm resistor, and then another leg connected to one leg of a resistor, which goes there. And then from the other leg, we have a connection to GPIO number 26. So now you can put the SD card back on the Raspberry Pi like this. Okay, put it on flat surface. And finally, you can power on your Raspberry Pi. Welcome back. This is episode number 9 of this tutorial series on Raspberry Pi for complete beginners. Now that the hardware setup for the push button is finished, let's see how we can actually get some value from this button to know if the button is pressed or if the button is not pressed inside the Python code. So first of all, I'm going to do import rpi.gpio as GPIO, okay, as usual. We are also going to import the time module because we're going to need it. I'm going to do gpio.setMode with gpio.bcm, okay, that doesn't change. And finally, at the end, I'm going to do gpio.cleanup. So for now, quite classic code. And now I'm going to create a variable to store the button pin. So let's simply call it button pin. And this will be GPIO number 26. Okay, and why uppercase? Because, well, you can use lowercase variables that you will change later, and you can use uppercase variables to kind of say to yourself later on, don't change that variable. Okay, of course you are able to change it at any time, but you use the uppercase. It's kind of a convention with Python that this is a variable you will not change in the future. So I have my button pin 26, okay, for the GPIO 26. Now I'm going to do gpio.setup button pin. So just like we did with the LED pin, but then instead of doing GPIO.output, I'm going to do GPIO.input, so just in. So now the button is set as an input. So we are going to read from that button. And to read from the button is simple. With LED you used GPIO.output. Here you are going to use GPIO.input. And put, of course, the pin. So button, pin. So you only have one parameter. Here is the name of the pin. And this pin should have been set as GPIO.in previously, so you can use that. So here, this return high or low. And if you want to actually see the result on the shell, here you are going to need to print high or low here. So let's print that. So let's just run the script and let's name it push button. Okay, and you can see 0. So sometimes when you print high or low, it will be printed as 0. So now, if I press the button and if I run the script again, you can see now we have the value 1. Okay, I remove anything, so the button is not pressed anymore, and now you can see 0. So as you can see, it's quite easy to read the value from a push button. And now what we can do, for example, to improve that code, we could do while true, print the button every second. So you are going to do time.sleep with 1. So every second you are going to print the value from the button. So I can see 0, 0, and then I press the button, 1, okay. And if I remove my finger from the button, it comes back to 0. Well, so as you can see, once you have understood how to power on an LED with the RPI.GPIO library, well, it's quite easy to handle a push button. Okay, you just need to do GPIO.setup with GPIO.in instead of out, okay, for input GPIOs. And then you simply have GPIO.input with the number of the pin. So you can read that and you can process it in your code, or you can just print it like we did here. Wow, you are still here! Congratulations! Why I say that is because actually many people give up on tutorials after just a few minutes. But you have made it until that point. And I have the feeling that you're going to continue and become a pro Raspberry Pi maker. If you are enjoying this tutorial so far, you can check out the full course named Raspberry Pi for Beginners, which actually contains 10 hours of hands-on video lessons. I will leave a link in the description if you're interested. Alright, and let's continue with the video. Welcome back to episode number 10 of this tutorial series on Raspberry Pi for complete beginners. This tutorial is actually a challenge I'm gonna give you to make you practice on what we have seen before in the tutorial series. So first, I will explain what you have to do, and then I will do the solution with you step by step. In this challenge, what you have to do is simple. You have to power on the LED when the button is pressed. And when the button is not pressed, you power off the LED. So you can start from a blank page, okay, and start from scratch to do this activity. Of course, you can rewatch the previous lessons, and you can also get help from the previous code that you have already written. So the result should be this one. When I press the button, the LED is powered on, and when I release the button, the LED is powered off by default. Alright, and now you can press pause on the video, try to do the challenge by yourself, and then watch the solution. So first of all, we are going to write the basic code that we need to simply be able to use GPIO. Okay, so the configuration stuff first. So import rpi.gpio as GPIO. Then we also will need to import time because we are going to use time. Then GPIO.setMode with GPIO.bcm. Okay, so we can use the GPIO number. Then we are going to set up our LED and set up our button. So GPIO.setup, we need to provide the LED pin. So I'm going to do that LED pin 17. Okay, that doesn't change. Button pin 26, that doesn't change either. And then GPIO setup, LED pin with GPIO.out and GPIO setup with button pin GPIO.in. Okay, make sure you don't mix those. So now everything is set up. I'm going to write GPIO.cleanup for the end of the program before it exits. And now, okay, what we want to do, we want to keep monitoring the button state. So every time the button states change, we can simply modify the LED. So we can power on the LED or we can power off the LED. So what I'm going to do, simply while true. So I'm going to make an infinite loop so we can always check on the button. And I'm going to do if GPIO.input button pin. Okay. So what we do is we check, first we read, okay, what is the value from the button. If this is equal to GPIO.high, okay, so the two equal sign, we test that condition, we read the button state. If the button state is high, and what we do is we power on the LED. So GPIO.output LED pin with GPIO.high. And I can put else, okay? I could put if GPIO input is equal to low, but anyway, it is a binary state. So if it's not high, it will be low. So I can just put else and GPIO.output LED pin GPIO.low. Okay, and actually let's try that. So run the script. I can save it as activity 5. And let's see what happens. Okay, so that works. We continuously check the button state, and then depending on what is the button state, we set the LED to high or low. And finally, the cleanup is here, but as you already know, because we keep going in this while loop, then when I stop the program, this will not be executed. So when I run the script again, we will have that warning, okay, but this is something you can skip for now, and that we're going to solve later in this course. And actually this program is running great, but we will need to add something else, okay? We will add a time slip with a very low amount here between each iteration of the while loop. Because right now, what is happening is, you give a while true, and inside you just execute some code, okay, that doesn't slip, that doesn't wait for anything. So it will execute the code at the max speed from the CPU, okay? So to make you understand that, I'm just going to go here, okay, and go to accessories and task manager. And let's put that here. Okay, as you can see, the CPU usage is something above 25, so 27% here. You have to know that on the Raspberry Pi, you have 4 different cores. So you have 4 CPUs. So if you have a CPU usage of 25% here with one program, it means that one CPU is full with just one program, okay? If I stop here, I go back to Task Manager, you can see that the CPU usage with nothing running should be about 2% here, okay? I just have the Tony IDE and some other stuff, but the CPU usage is really low. And if I run the script, the CPU goes up to 27%, okay, so it means that we added 25% of CPU usage, and because we have 4 CPUs, it means that one CPU is completely full with that program, okay, which is not that great. So what we can do here, in the while true, we can simply add time sleep, for example, with 0.01. And you are going to add that not inside the if or inside the else, okay? Make sure you add it inside the while true at the same scope as here, okay? So it gets executed every time you enter the while true. So you can put it here if you want, or you can also put it at the beginning. It's basically the same because this block of code will keep being executed again and again and again. So what this will change is simply that now every time we are going to wait 0.01 second, which means that this block of code will be executed at about 100 Hertz, which means 100 times per second. And running that at 100 times per second is really enough, okay? You don't need to run it faster for this application. So now if I run the script again, so it is running, I go to the task manager and you can see the CPU usage is now about, so let's wait, okay, it's 5%. And it goes even back to 2%. So we are using now, you can see 3% now. We are using a very small amount of CPU, okay? If you just put a time sleep with a low amount like this, it will make when the program sleeps, okay, it consumes really little or none of the CPU resources, and it's much better to actually use lower CPU usage. So keep in mind that when you are actually running an infinite loop, okay, an infinite loop on purpose, in that case, when you are, for example, reading something and taking an action depending on what you have read, it's better to add a very small time sleep, okay? You can put 0.01 or you can go lower or you can go higher, but just put some sleep, okay, to make the program wait, so it will use much less CPU. Welcome back, this is episode number 11 of this tutorial series on Raspberry Pi for complete beginners. In this tutorial, we are going to come back to the circuit we have built in a previous episode of the series. So far, we have one LED and one push button connected to the Raspberry Pi. We are going to add 2 more LEDs so that we can create more complex and funnier applications. So, first of all, make sure that one, you have correctly shut down your Raspberry Pi, okay, from the software, directly from the Raspberry Pi desktop. Then you wait a few seconds, and then you can remove the power cable. I'm going also to remove the SD card just in case, so I don't damage it. I put it on the side, and I'm going to add 2 more LEDs, so you can just pick any color you want, right? And for those 2 LEDs, I will need 2 more resistors. Those are 1 kilo ohm resistors. I also need 2 more cables, so 2 wires, male to female. So the best thing is, if you have different colors, then use different colors, okay, so you don't mix them. And try to avoid using red and black. Red for power, black for ground. So let's take our breadboard here, our circuit. We don't change anything here that already exists. We are going to take, so let's take our first LED, and you can see that we have short leg and long leg. So we are going to connect the shorter leg to the ground. So let's put it somewhere here. So short leg to the ground and the longer leg to another pin, to another dot here. Okay, so we have that. And now we are going to do the same thing with the third LED. So let's check which, okay, that is the shorter leg. We are going to connect it to the ground. So let's place it here, for example. It doesn't really matter the exact place, okay? So we have one LED, two LED with the short leg of each LED connected to the ground, which is the blue line here, and we have already the black wire. Now I'm going to take one resistor, put it on one of the legs, so the longer leg of this LED, and another dot here. So make sure you don't connect, of course, this leg of the resistor with the longer leg of the LED, that one, okay, because you don't want to mix everything up. So just take one free slot, okay, then do the same with the other resistor. Put it inside, make sure it's correctly inside, okay? Okay, and make sure the wires don't touch each other. Looks good. Now you take one wire, so you plug the male into here, okay, with the other side of the resistor. And you are gonna plug the female part just next to that one here. So you have already plugged the first LED to GPIO number 17, and now we are going to plug the second GPIO to number 27, okay? So it's very easy here, it's just always on the same row, okay? The internal side of the Raspberry Pi. You have the ground here, which is number 5, and then number 6 you have GPIO 17, number 7 you have GPIO 27, and that is where we are going to put our second LED. And our third LED, we are going to put it on GPIO 22, which is the next one. And let's just plug it here, and let's put it right there. Okay. So we have, as you can see, 3 in a row. So 17, 27, and 22. And make sure, this is why you should be careful with where you plug your wires, because the next one here, the very next pin, if you look at the image with the pin out, the very next pin is a power pin. It's a 3.3 volt pin. So you don't want to directly connect a wire to that from somewhere that you are not sure. Okay, this may damage your board. All right, so the hardware setup is finished. We have, we check that LED here. The short leg is connected to the ground. The long leg is connected to one leg of the resistor, which is going to another dot, and which is then going to right here, that GPIO. And the same for the green LED here. The shorter leg to the ground, the longer leg to one leg of the resistor, and then going back to GPIO. All right, now you can put back the SD card in the slot, make sure it's correctly inside the slot, and power on the Raspberry Pi. Welcome back to episode number 12 of this tutorial series on Raspberry Pi for complete beginners. This tutorial here is yet another challenge I'm giving you, with first the explanation of what you need to do and then the step-by-step solution. Now that you have 3 LEDs and 1 push button on your circuit, let's make a slightly bigger project. Here is the result you should get for this challenge. When starting the program, all the LEDs are powered off. Then, when you click on the push button once, the first LED will be powered on and all the other will be powered off. When you click again, the second LED will be powered on and the other powered off. Then you do the same for the third LED, and after that you go back to the first LED and so on. One important thing here, you want to make a change with the LEDs only when the state of the button switches from the state not pressed to the state pressed. So if you keep your finger on the button, nothing more should happen. And when you release the button, nothing should happen either. So in your program, you will certainly have to keep the previous button state in a variable. So for example, in previous button state, okay, which will contain the GPIO input from the push button. And you will use that variable to compare the previous and the current value, so you know exactly when you should toggle the LEDs. Alright, and now you can press pause on the video, try to do the challenge by yourself, and then watch the solution. So I'm going to remove that, and first of all, well, we are just going to write the configuration code, okay? So the import lines, the GPIO setup, etc. So we are going to import rpi.gpio again as GPIO, import time library that we are going to use, and then as usual GPIO.setMode with GPIO.bcm, finally GPIO.cleanup, and now we are going to create variables. Okay, one variable for each LED and push button, just to know the number of those components. So let's, for example, use LED1 pin, which is 17, then LED2 pin 27, and LED3 pin 22. We also have the button pin, which is 26. Okay, so that is very important. Make sure you have the correct numbers. Okay, the number should be exactly the one that you have used to connect the wire, okay, for each component. Now here let's do GPIO.setup with LED1 pin. Let's make it GPIO.out, so as an output GPIO. Okay, we do the same here for LED2, and we do the same for LED3, and then GPIO.setup button pin GPIO.in for the push button. Okay, so that is the end of the configuration. Okay, that's quite a few lines, but it's just the basic stuff to set the GPIOs as input or output. And now we can actually use the GPIOs. So first I'm going to initialize the state of all three LEDs, okay, just to be sure. So GPIO output LED1 pin GPIO.low. Okay, we want to power off all the LEDs. So let's do that. Great. So now it is the mode is initialized and the state is also initialized. So now we arrive at the core functionality of the program. So as I previously told you, I'm going to create a previous button state variable, okay, and I'm going to show you how we use it in the while loop. So I'm going to do GPIO input button. Okay, we need to initialize that variable with a first value. So I'm going to use that previous button state variable to check the current button state with the previous button state and see when we switch from GPIO low to GPIO high. So now I'm going to write while true. Okay, we are going to just do a while true like we did before. Okay, so we can continue monitoring the button state and always make sure that the program is running. And first I'm going to do time.sleep 0.01. Okay, so we make that while loop run at 100 Hz, or in other words, 100 times per second. And the time slip, you can add it at the end of the code or at the beginning. Here it really doesn't matter. So I'm just going to add it at the beginning so we are sure that first we don't forget it, and second it is correctly indented. Right, so now I'm going to do what? I'm going to read the button state. GPIO input button pin. So I read the button state, and now what I need to do is I need to compare the button state with the previous button state. Okay, so let's say the button state was high and now it is low, so it will be different. So I'm going to check if the button state is different from the previous button state, and as you can see here, of course, we have access to previous button state because it is in a more global scope. Okay, that's why we have declared it here. So if the current button state, which I just call button state, is different from the previous one, it means that we are either going from low to high or high to low. So either we press the button or we release the button. And the first thing I'm going to do here is actually to set previous button state to the current button state. Okay, so why do I do that? Well, simply because when the state is different, you want to, of course, update the previous state with the current state, so you don't always enter that if. Okay, you just want to check when the state is going from low to high once or high to low once. So you need to keep a variable previous button state, and every time you fill it with the button state when it has changed. So let's say it was low and now here you read it, it's high. So you will enter that if, because the condition will be true, different, and then the previous button state will be high. Okay, which means that the next time we enter the while loop, if the button state is still high, then this won't work and we don't enter that if. Okay. Now what I can do is, because here we have two cases, either it's low to high or high to low. So I'm simply going to check with another if the button state, so the current one, is GPIO high. And with that, we only check the condition from low to high. So when I enter this if here, this block of code, I know that the button has just been pressed. And this structure here with the previous state and checking the previous and the current state is actually quite common, okay, in robotics or when you want to deal with hardware stuff. It's good that you see that now because you will encounter that many times in the future. Okay, so now that we know that here we want to toggle the LEDs, now we have to focus on the LEDs. So actually, we need to kind of have keep a state, okay, for the LEDs, because we need to know when we should switch to LED 1 or LED 2 or LED 3. What I'm going to do is add here index, let's say LED index 0. Let's put it to 0, and we are going to say that if the LED index is 0, okay, then we are going to power, I'm just putting some comments now, power on LED 1, okay, and set the LED index to 1, okay, and then I have if LED index equals 1, so make sure you have the double equal. Okay, when you assign a variable, just 1 equal. When you test a variable, 2 equal. Then power on LED 2, LED index is equal to 2, and else we're going to power on LED 3 and say that the LED index is going back to 0. Okay, so what did I do here? Well, this is basically a simple state machine. Okay, we start with a state which is 0, okay, just to represent the index of LEDs, let's say 0, 1, and 2. And when it is 0, so we enter that while. When it is 0, then we are going to power on the LED 1 and set the LED index to 1, okay? So then if this is true, the elif and the else will not be executed, all right? So after we have powered on the LED 1, we go back here, we go back to the while loop, okay? And once the user has pressed the button again, then we enter that if again, and now LED index is 1. So we are not going to execute that block of code. We are going to execute that block of code, okay, and power on LED 2, and then set the LED index to 2. So next time we press the button, we go inside the if again, and LED index is not 0, it's not 1, so we go to the else, and it is where we can power on LED 3 and of course set the LED index to 0. So next time we go back to the first condition. All right, so to power on the LED 1, it's simple. I'm going to do GPIO output LED 1 pin GPIO dot I. And of course, what I also need to do is to power off the other LED, okay? Because if I don't ask to power off the other LED, if they were powered on, then they will not be powered off just by themselves, okay? GPIO low, and let's also do that for LED 3. Okay, and now to power on LED 2, it's the same. So I'm just going to paste that, but instead of here I'm going to put low, and here I'm going to put high, and the same for LED 3. I'm going to put low here and high here. Okay, so you can see the first time we have high, low, low, and then low, high, low, and then low, low, high, and then going back to high, low, low, etc. Well, it seems that the code is finished. Let's try that. Let's see if we have any error, okay, because I haven't checked for errors yet. So let's run the code. Let's name it activity 6. So as you can see, first all of the LEDs are powered off. Now I'm going to press on the button once, and as you can see, the first LED is powered on. If I press again, the second LED is powered on, I press the third, and I press again, going back to the first one. If I keep pressing the button without releasing the button, then nothing changes, okay, right? And when I release the button, also nothing changes. It's only when I actually press the button, so when the button state is going from low to high, that we are changing the powered on LED. Welcome back. This is episode number 13 of this tutorial series on Raspberry Pi for complete beginners. So you can use the Raspberry Pi to control hardware components, yes, but there is so much more you can do. For example, you can create and host a web server on the Raspberry Pi. That's what we are going to focus on this tutorial and the following ones. I will show you how to create a web server using the Flask framework with Python. This skill set will be super useful for your next projects. And let's jump directly to the code. So to use Flask, you are going to do from Flask import Flask. Okay, Flask uppercase here and Flask lowercase here. This way you can import the Flask framework. And you can notice that if you run the code, it will work because Flask is already installed as a Python module on your Raspberry Pi operating system here. So one of the first things you will need to do in your application is to initialize Flask. So you're going to create an app variable, for example, and Flask, right? Flask with parentheses, and inside that underscore underscore name underscore underscore. Okay, this is a special thing in Python, and this will initialize Flask. Okay, So there is really nothing to understand here. It's just you have to write that to initialize the application. And then to actually run the server, so we are going here to create some routes that correspond to different URLs. Okay, this will be the main functionalities of the application. And then at the end we are going to do app.run to run the application actually, and we need to give host equal 0.0.0.040. And this line here will run the application. It will kind of block the program here and run the application until you stop the program with Ctrl+C, for example. So this is basically the main structure you will have in all your programs with Flask. As I told you, there is nothing really to understand, just this is the syntax to write. And here you can see we have host 0000. This is so every computer in the network will be able to actually connect to that server. So now I'm going to create a route, and to do that I'm going to do @app. So app, this is the app from there, .root, and I'm going to give the root inside the parentheses here, and I will simply use slash. So slash will be the home page. Okay, when you go to a website, let's say website.com, the slash is basically when you just go to website.com and you don't add any other text in the URL. Okay, if you go to website.com/example, then you will need to create a route with /example. Okay, and so this will create a route, and you need to associate a function to it. So we are going to call that function index. Usually the index goes to the main root URL here. So when you go to the server with that URL, the index function will be called, and it is expected to return a string with text or HTML or whatever, and this will be then interpreted by your web browser and printed so the user can actually see the result. So we are going to return here simply a string, hello from Flask. So this should appear on the web browser. Okay, I'm going to run that. Let's save as web server. Note that it's important, you can't name the file flask.py, okay, otherwise you will have an error. As a best practice, try not to name your file with the same name as a module that you use in that file. So here you can see the server is running, okay, running on HTTP, and then you have the URL, and the port is 5000. So I click on that, and as you can see, a new web browser has been opened, and we see hello from Flask. Great. And as you can see, when we actually call the URL, you have a new log. If I do enter here, okay, we have something new, get slash, so this is the main root, and this we call the index function. Okay, and then you can see 200 means that it was correctly done and the result could be delivered. So here you can see the URL is 0.0.0.0 and then colon 5000. So this is the IP address basically, and this is the port. So if you don't put 5000, then of course you will have an error because you need to provide both the IP address and the port. Now I can also use 127.0.0.1. Okay, this works. When you host an application on the computer, this IP address is kind of reserved, and it means that you are just reaching to the computer you are currently in. Okay, so 127.0.0.1, and you can also use local host. Okay, this will do the same, localhost. Now here, as you can see, I am using a web browser inside the Raspberry Pi. but maybe you want to use a web browser outside of the Raspberry Pi with a computer that is connected on the same network, so you can get access to the web server from the Raspberry Pi on a different computer. And in that case, it's very easy. I'm going to open a terminal and I'm going to do hostname -I to get the IP address of the Raspberry Pi. So you should already know that, okay, because you are connected to it. So this is the IP address of the Raspberry Pi in the network. So if I just write the IP address here, 192.168.43.56. And as you can see, I also have the results. So from another computer, let's say this is a web browser from another computer, I can access the web server in the Raspberry Pi using directly the IP address on the network, and then of course followed by the port. And if you want to change the port, okay, instead of 5000, you may want to use a different one. In that case, so let's stop the application. You can add here an argument port, and let's say 8500. If you want to use a different port than 5000, so you can choose any port you want, just take a port that is at least 1024, okay, because the ports before 1024 are already reserved. So now I'm running here the script, and if I go back to my application, so of course now there is nothing on port 5000. If I go to port 8500, I can find the application. Welcome back to episode number 14 of this tutorial series on Raspberry Pi for complete beginners. So in this tutorial, I will show you how to combine the Flask server and the GPIOs together in one application so that you can create a web interface to control the hardware components you have connected to the Raspberry Pi. Make sure you have watched the previous tutorial because we are going to start directly from there. Let's now add a new URL to this web application. So now let's say that I want to do slash something. So if I do slash, of course, this is the main slash, the main root. Now let's say I want to check the push. I want to make an URL for push button. So for this, of course, you have a 404 not found result, okay, because this URL simply doesn't exist within this application. So we are going to create a root for that URL, and the functionality here we are going to do is simply to print whether the button, the push button, is pressed or not pressed. So we are going to link here the web application with Flask with the GPIO functionality. And as you will see, this is not really difficult to do. So here, the formula is kind of always the same, at app.root, and then I will provide the root, and the root will be push button. So don't use spaces if you want to make multiple words, okay, in a root. The best way to do it is to use dash, okay, dashes everywhere. Let's name that function push button, so this time with an underscore. The name of the function doesn't really matter, okay, it doesn't need to be the same as the URL, it can be anything, just make something that is meaningful. So actually, instead of push button, we could do check push button state. And let's just return an empty string for now. I'm going also to remove the port. So we keep the basic, the default port. Okay, so now let's just run that web server. I'm going back to here. I have to put 5000 and it works. Okay, so we don't have anything on the screen because the string is empty, okay, but it works. We have the 200 result here, okay. If you have an URL where you have nothing here, you have the 404 result, okay. Now we have a root and we can get access to it from the web browser. So let's make something with that. So I'm going now to initialize the GPIOs. Okay, so import rpi.gpio as GPIO. so I can set up GPIOs before or after this doesn't matter here. I'm going to do it here, GPIO.set mode with GPIO.bcm, so we use the GPIO numbers, and then GPIO.setup, and I'm going to create a variable here, button pin, which is 26 on the hardware setup that we have. So button pin GPIO in. Great, so the button is initialized, and now I'm going to do if GPIO.input with the button pin. If it is equal to GPIO.high, which means that the button is pressed, I'm going to add one indentation here and return button is pressed. Now, if the button is not pressed, I'm going to return button is not pressed. And note that here I could do that, else, okay, if the state of the button is GPIO high, we'll return that, else we'll return that. But you can see that the else here is not mandatory, because why is that? Because when we do return, then we just return and we exit the function, so everything after that will not be executed. So if the button is pressed, we directly return that. And if we go to line 18, it means that the condition here was false. So basically, when you just want to check something and return, then you don't need the else, okay, because the else is kind of implied here. So if button is pressed, we return from line 17 with that text. If not, then we go to line 18 and we return that text. Now let's run that, and let's go here and let's refresh. Button is not pressed. So now I'm going to push the button, keep it pressed, okay, and I'm going to refresh, and you can see button is pressed. I refresh, now I release the button, and button is not pressed. So great, now you have an application that can tell you the state of your GPIOs, and you can run actually that application in any computer connected to the same network as your Raspberry Pi, okay, even your phone. You can just go to that URL from your phone. It should be, of course, connected to the same network again, but you can get any information from your GPIOs from any device in your network. And welcome back to episode number 15 of this tutorial series on Raspberry Pi for complete beginners. In this tutorial, we are going to control the LEDs on the Raspberry Pi circuit from a web application using Flask and Python. And once again, like I did previously in this series, I'm going to show you the problem we want to solve as a challenge, and then I'm going to write the solution with you step by step. So in this application, you are going to create a basic Flask app like this one, initialize GPIOs, and you are going to add a new root here. So I'm going to just show you the URL you should have. So app.root with, so you will have /LED/ and then I'm going to write that int LED pin /state /int LED state. Okay, so what is that URL? So you can see we have the LED word that will not change and the state word that will not change. And here, this is so you can give a number. Okay, you will give the pin of the LED inside the URL. So for example, you will give 17, here are 27, etc. And here you will give the state, so basically 0 for GPIO low and 1 for GPIO high. So if you want to power on or power off the LED. So this URL makes you choose one LED pin and the state to put on the LED. And this is the syntax, okay? This is basically the syntax. so you can get a number and read the number inside the function. So now the function will be, let's name it trigger LED, and you will have two parameters, LED pin and LED state. Okay, so that are the two parameters that you get from the URL. Okay, so with that, I will leave you write the function, and you can of course have here LED pin list, which will contain 17, 27 and 22, which are the three GPIOs we are using as for now in this course. So your challenge is, so first you are going to initialize, of course, the LED pins, so set them up to GPIO out, initialize their state to GPIO low, okay, and then here you are going to check, so you will need to validate, okay, the LED pin. You don't want to just do a GPIO output on any LED that the user gives you. You want to validate that the GPIO is in fact in this array, okay, and then validate the state if it is 0 or 1, so you can power on or power off the LED. Alright, and now you can press pause on the video, try to do the challenge by yourself, and then watch the solution. So first of all, of course, we need to do the setup. So I'm going here, I have initialized the button pin. What I'm going to do is do for pin in LED pin list. So I'm going through the array of LEDs, okay, and simply do GPIO dot setup pin. So this will be the pin we get. So first 17, then 27, and then 22 with GPIO dot out. And then I'm going to also here, so this is initialization, I'm going to do for pin in LED pin list again, okay, and this time do GPIO dot output pin GPIO low. So we power off all of the LEDs. Note that I could have put that also in this for loop. This would have been the same, just put the output after the setup. But here I think it's a good practice to differentiate the different stage of the initialization. So first you just initialize the mode of the pin, and then you initialize the state of the pin in a different line, okay? So the LEDs are now set up. What we can do is go here in our function, and I am first going to check that the LED pin is correctly inside the array. So I'm going to do if not LED pin in pin, what's the name again? LED pin list. So if the LED is not in that list, we are just going to return wrong GPIO number, okay, and maybe plus str LED pin. So str, because this is an integer now, so if we just concatenate a string with integer, this will not work. So that is the first check. We check if the LED is correct. So now you can only give 17, 27 and 22. Any other number will not work. And now we can handle the state. So we know the LED pin is correct. We can do if LED state is equal with two equal sign, okay, don't forget that, 0. We can do GPIO dot output with the LED pin variable and GPIO dot low. Then we can do if LED state is 1, again with two equal sign. Then we do GPIO dot output LED pin GPIO dot high. And we can add an else, okay. If the LED state is not 0 and it's not 1, we are going to that else, and simply we return state must be 0 or 1. So in that case, we have a correct GPIO number, but the state is not correct. And just one more thing we need to do is, because when we have LED state 0 or LED state 1, we could just return something like return OK. something like that. And you will have to also use return OK in that situation. So what we can do, instead of writing return OK twice, is just go here and do return OK. So let's see what happens in that function here. So first we check if the LED pin is in the list. Okay, if it's not in the list, we just return a string from there. If it's in the list, we continue. We go to line 30. We check if the state is 0. If yes, then we execute this line, and then it will exit from the if and go to line 36 and return OK. Right. Now let's say it is false, then we go to line 32. If the LED state is 1, we execute that line and then go out of the if and execute line 36, return OK. And finally, if this condition is false and this condition is false, we go to line 34, we go to the else and we return another string. So now let's, actually I'm going to save as activity 11 and let's run activity 11. Right, let's go to here. So we still have, of course, the push button, but now I'm going to do LED slash, let's do 17 slash state and slash 1, and let's see what happens. Great, you can see the LED, so the first LED is powered on and we have the OK. And when I put 0 here, well, the LED is powered off. Now let's say I put 2. As you can see, we have the error, state must be 0 or 1. Okay, the important is that you don't get an error here like 404, or you don't get an internal error in your server. You have to kind of handle every possibility and give the user a correct message of what you expect him or her to do. So now if I go back to 0, okay. If I try another LED, let's say put 18, which should not be a correct number, and you have the message wrong GPIO number 18. Okay. So if I want to power on the second LED, this is number 27, state 1, let's call that, and okay, and you can see the second LED is powered on. Now if you want to power on the third one, you can just do 22, okay, and then you can power off all of the LEDs. So let's power off LED 22 and then let's power off LED 27, okay, and all of the LEDs are now powered off. Hey, this is Edward. I hope you enjoyed this tutorial series a lot and that you could get some real value out of it. Now, this series is actually a free extract from my much larger course named Raspberry Pi for Beginners. This complete course contains 10 hours of content and will take you from a complete beginner to a Raspberry Pi maker with a strong intermediate level where you become really autonomous and confident to start any Raspberry Pi project you want. So if you like the way I teach and if you want to go further with Raspberry Pi, well, I recommend that you check the course out. The link is in the description. And just in case you are wondering what you're gonna learn, well, here is a sneak peek of what's inside the course. So here I am inside the course, and you can see we have actually 15 different sections or 15 modules. And here is basically how the course is built. So we start with the foundation, so how to install Raspberry Pi, the Raspberry Pi basics, Python 3 programming, okay, how to use the GPIOs, and then we build, on top of this foundation, we build many different skill sets with different components or different functionalities. For example, we're going to learn how to use a PIR sensor to detect a human presence, how to use the terminal on the Raspberry Pi, how to send an email from the Raspberry Pi, how to use the camera to take some pictures and videos, and also how to use a web server, which is actually what we did in this tutorial series. And at the end, we're going to build on top of all of that a big final project where we combine everything that we have learned in the course. And so you can see here on the left, I have the complete outline. So here is the installation section that you had in this tutorial series. And then we have, well, 2 sections on Python programming, okay, with a complete recap of Python using the Raspberry Pi and a few more activities and challenges. Then we see how to build the circuit, which is also something we did in the series, how to control the GPIOs. We practice more with the GPIOs, so you will find more activities actually here than in the series. And then here the real fun begins, okay? We're gonna learn how to use a PIR sensor, so I'm gonna show you how to tune the sensor, how to add it to the circuit to read the data, another activity to practice, and then how to use the terminal, also how to use Python in the terminal, which is very useful in the Raspberry Pi. And after that, we're gonna see how to send an email with Python from the Raspberry Pi, how to use the camera module. Okay, and you can see that in every section we have a new activity, so you can practice even more. Then we have this web application, okay, with Flask, which is what we did, but also with an additional activity. So we have 11 activities or 11 challenges in this course. And well, that's not all, because you have this big final project. As you can see, I will show you the overview of what we're gonna do. So in this project, we're gonna create a alarm system using the PIR sensor to detect when someone is passing by. And at that point, you're gonna take a photo with the camera and you're gonna send it to your email address and also make it available with a web page using a web server. Alright, so as you can see, there is a lot to do in the course and there is a lot to learn, and after this you will be really confident with the Raspberry Pi to start any other project you want. Alright, thank you for watching and I hope to see you in the course.